Okay, so another trigonometric substitution question. And once again, we know trig sub is going to work here because we have difference of squares under a square root. And once again, to the power of 3/2 really means the square root of, and then raised to the third power. What substitution would be good to use here? Let x be 3 secant or 3 sine? Sine, right? Because the number square is coming first, as opposed to the variable square coming first, right? So 3 sine theta. Right away, let's find dx, which is 3 cosine theta d theta. And I'm going to replace everything now with the thetas. Where I see dx, I'm going to write 3 cosine theta d theta. On the bottom, instead of having a 9 minus x squared, what should I be writing? 9 minus what? What is the square of 3 sine theta? 9 sine squared theta. And everything should be raised to the 3/2 power. But before I raise it to that power, let me simplify the inside part. The inside part here is something you can factor out a 9 from. So 9 times 1 minus sine squared. And what do we know about 1 minus sine squared? Cosine squared. So this whole thing, 1 minus sine squared. First we had factored out the 9, and then we're writing it as 9 times cosine squared theta. Okay, so this I will put in my next step. So the original integral is equal to, on the top we have 3 cosine theta d theta. On the bottom, we have 9 cosine squared theta, all together to the 3/2 power. And 3/2 means first take a square root, and then raise to the third power. So what will you get when you do that? When you first take a square root, what would you get here? 3 cosine theta, assuming we're dealing with positive values, 3 cosine theta, and then raise it to the third power, 27 cosine cubed theta, right? So first you get 3 cosine theta, and then you raise it to the third power, and you get 27 cosine cube. And on the top still you have 3 cosine theta. So 1/9 the integral of 1 over cosine square. Okay, some of you I noticed got stuck at this point. Any thoughts about how we could integrate this? Can we rewrite it? Exactly. Grace has the right suggestion. 1 over cosine square is the same thing as secant square, right? And what do we know about the integral of secant square? Tangent theta. Okay. And finally, we need our triangle to get rid of that tangent theta. So this is where we must go back to the original substitution, right? Let x be 3 sine theta. From there, we know that x over 3 is equal to sine theta. We know that from here. So I will label the size of this triangle as opposite over hypotenuse as x over 3. Opposite over hypotenuse. So the third side is the square root of what? So what will the third side be? The square root of 9 minus x squared. Thank you, Courtney. Okay. But what we really want from this triangle is the tangent theta. Tangent is opposite over adjacent, right? So let's write the tangent theta from this triangle. And that is x over the square root of 9 minus x squared. How many of you were able to get all this far before I put the solution on the board? I know since on the back earlier I saw that. So about a little less than half of the class. So hopefully as we do more and more examples, you know, you're going to get to the point where you can do the entire question correctly. But as with all sections, you know, you need to do lots and lots of practice, and eventually you see all the possible places to make the errors so you don't repeat those errors in future problems. All right, we'll do another example. Which one? Next. Okay, let's try this one. Find the integral of the square root of 25 minus t squared. For this question, I'm going to give you a hint because there's going to be a point where you need to know a certain identity, and that one I don't expect you to know, so I'm going to give it to you. Please note that sine of 2 theta equals, does anybody know by any chance a double angle identity from trigonometry? Does anybody know the identity for sine of 2 theta? It's 2 sine theta cosine theta. Now, I didn't expect you to know this. If you remember it, fantastic. If you did not remember it, I'm providing you with the formula. So sine of 2 theta equals 2 sine times cosine. Keep this aside somewhere in your solution. You may need this, so please keep this aside. And as always, I'm going to give you a little bit of time to work on this before we put the answer on the board. Okay, so would everyone agree with me that the choice for substitution should be let t be equal to phi sine theta? Would everybody agree with that choice? Because constant square minus variable square, immediately find dt. Again, a very common mistake to forget the dt, to replace that in the next step. So let's try not to do that mistake. So differentiate both sides, you get 5 cosine theta d theta. So I come back over here. For the square root, I'm going to put 25 minus t squared, and t squared is 25 sine square. And dt is based on what we just found, 5 cosine theta d theta. Now we need to simplify the square root once again. So that square root, what's inside the square root can be simplified as, take out a 25, and then what is 1 minus sine square? Cosine square. So when I rewrite the whole integral, I have under the square root sign just a 25 cosine square theta. And on the outside, I have 5 cosine theta d theta. Okay. Any questions up to this point? Any questions? Now we're ready to simplify the square roots, right? How will that quantity come out of the radical? Yes, Tim? 5 cosine theta. That's how it's going to come out of the radical. So now we're going to have 5 cosine theta multiplied by 5 cosine theta. In other words, by the way, this was the hint I gave you earlier. At the moment, I'm going to erase that. That was the hint for how to simplify sine of a double angle. I'll give you that later, that same hint. Okay, so at the moment, I'm simplifying this integral as 25 cosine square theta d theta. At this point, we need to remember how to integrate cosine square. Any thoughts about that? anybody remember a reduction formula for the cosine? A power reduction formula, as they call it. For cosine squared, the formula was the formula was 25, the integral of 1 plus cosine of 2 theta all over 2. This was also on the original handout I gave you at the beginning of the semester, all the integral formulas. What if you had to integrate sine squared? What was the only difference there? There was a minus in the middle. That's the only difference in the formula. So I'm going to factor out the 1/2, so you have 25 over 2. Now integrate the 1, you get theta. Integrate the cosine 2 theta. Any thoughts? Sine 2 theta over something, right? What is the integral of cosine 2 theta? Over 2, exactly. Let me put this in 2 steps so that when you're looking back, maybe, okay, so first of all, we factored out a 2, so we're left with this integral. Now we're integrating it. That gives me theta plus sine 2 theta over 2. Again, all I have to do is replace the thetas, replace the sine function, and then we'll be done. The only problem is if I were to create a triangle here, which I will, that triangle will have a theta in it. It's not going to have a 2 theta. So that's why I gave you that hint about sine of a double angle. Sine of 2 theta is the same as 2 sine theta cosine theta. There's an identity for that. So that one I'm giving you. So sine 2 theta is the same as 2 sine theta times cosine theta. Okay. Now the 2's cancel out. So we can write it as sine theta times cosine theta plus c. And looking back to our original substitution, we had said let t be 5 sine theta. This tells me that t over 5 equals sine theta. So how will we label the sides of this triangle? Opposite is what? T, and hypotenuse is phi, because sine is opposite over hypotenuse. So that means the third side should be 25 minus t squared. I need 3 things. I need to know what theta is, I need to know what sine theta is, and also what cosine theta is. Let's begin with theta. What could I write for theta? Since I know that sine theta equals t over 5, what is theta from there? Sine inverse of t over 5. Okay, now what is sine theta from this triangle? Because I need to replace this sine theta up here in terms of its equivalent. So what is sine theta from the triangle? T over 5. That was easy. And how about cosine theta? From the triangle, what is cosine theta? Square root of 25 minus t squared divided by 5. And don't forget the plus c at the end. You know, if we wanted to, we could multiply this 25 halves in the first piece into the second piece and simplify some of the constants, like the 25 from the second piece will be simplified with the 25 from the expression. So you could do that and rewrite the answer if you want to in more simplified format. I think I'm going to go ahead and do that anyway. So first multiply it with the first term. And now if you multiply it with the second term, what will happen there to your constants? The 25 from the top will cancel with the 25 from the bottom. So we'll have just 1/2, or t over 2, times the square root of 25 minus t squared. So that would be another way to leave the answer. Usually if you left it up to that point, everything's absolutely correct. I would not take off points, but it's better if there's a 25 there, you can cancel with the other 25. It's better to go ahead and do that. Okay. All right, here is another integral question which we will solve using trig substitution method. The integral of x cubed times the square root of x squared minus 4 dx. Once again, first we can look at this to make sure we cannot solve it with u substitution or any other formulas that we've learned in the past. And when we see difference of squares, especially under a square root, we know we can use the trig substitution method. So we're going to let x be equal to 2 secant theta. And I'm doing that because you have a variable squared minus a constant squared, so we know that the secant theta choice should be used. Okay, right away let's find dx, which is 2 secant theta tangent theta d theta. And now I'm going to go to this integral and replace everything in terms of thetas. For x cubed, I will write 8 secant cubed theta. For the square root of x squared minus 4, okay, first x squared, that is same as 4 secant squared theta, and then minus 4. Okay, looks like I ran out of space there because I want to rewrite dx in terms of theta as well. See if I can move this a little bit. Okay. So now for dx, I will write 2 times secant theta tangent theta d theta. Okay, simplifying all of that. First, I will factor out the constants together as 16 times integral of, okay, I see a secant cube up there, then I see a secant, so I'm going to combine them as secant to the 4th theta. Then I see a tangent theta up there, and under the radical, if we simplify that, factor out the 4, we get something like 4 times secant squared minus 1. And secant squared minus 1 is tangent square. So what we have is really 4 times tangent square under the square root. Now think about taking the square root of that quantity, and that should be 2 tangent theta. So we had to take the square root of these expressions, which turns out to be 2 tangent theta. That's what I will use in the next step. So I already have everything outside of the square root sign placed into this integral that I'm working on right now. And for the square root of that quantity, I will now write 2 tangent theta. Tangent theta, and don't forget the d theta. Okay, once again, factor out the constant. We have 32 times the integral of 2 tangent squared theta times secant to the 4th theta d theta. Now, we have done questions like this in the last section when we were doing trigonometric integrals. Let's think about what would be a good choice to reserve as du. And oftentimes there's more than one possibility. Here I'm going to reserve a secant squared theta d theta for my du. So the secant to the fourth I'm breaking down as secant squared times secant squared, one of which I have written down thus far. The other secant squared that comes out of that secant to the fourth, I will write as 1 plus tangent square. Again, that secant to the fourth was secant square times secant square. One of that went over here, and one of that went over here. And don't forget the 2 tangent square up front. So you can see that I am trying to write it in such a way that if I let u be equal to tangent theta, then du is secant square, and all the tangents now can be replaced in terms of u. The tangents will be replaced in terms of u, and secant squared theta d theta will be our du. So let me see something here. Okay, earlier I had factored out the 2 with the 16, so that became a 32. So I should not have any other 2's hanging in there. So that 2 was already factored outside. So what I have is 32 times the integral of the remaining quantity there. So rewriting that, 32 times u squared times 1 plus u squared times du. And that's a relatively simple integral. First multiply the u squared in, and then integrate. U to the third over 3 plus u to the 5 over 5. And remembering what u was, we bring that back in here. So tangent to the third over 3 plus tangent to the fifth over 5 plus c. But as always, we need to get rid of the theta using a triangle. And remember the original substitution for that. X was 2 secant theta. Since x was 2 secant theta is x over 2. So labeling the sides of this triangle, hypotenuse should be x and adjacent should be 2, because secant is hypotenuse over adjacent. And the third side will be radical x squared minus 4. Okay, what we need right now from this triangle is, first of all, tangent theta. As a matter of fact, to make things a little bit easier, I will first get common denominators in here. So multiply this top and bottom by 5, and this top and bottom by 3, and factor out a 15 from the denominator. So that leaves us with 5 times tangent cube of theta plus 3 times tangent to the fifth of theta. And again, before bringing in that tangent theta from the triangle, which we know will be opposite over adjacent, if I wanted to do a factorization, at this point I could even factor out the tangent cube as well, and I could leave this as 32 over 15 times tangent to the third theta, quantity 5 plus 3 tangent squared theta. Okay, tangent cube will be x squared minus 4 in square root sign to the third power. That is the same thing as this quantity to the 3/2, but tangent theta also had a 2 on the bottom. Cubing that, you get an 8. times 5 plus 3 tangent square, and squaring the tangent theta, we will have x squared minus 4 divided by 4. So once again, I will get common denominators. Just multiply the top and bottom by 4 over 4. And simplifying it, so we keep simplifying this. It's taking us a little while. It's one of the more challenging ones that you will see in this section. But let's just continue our work until we can no longer simplify this. So technically, we're done with the integration process. You know, we brought the variable back. Technically, there are many ways you could leave the final answer, and it'll be acceptable. But I want to take this one to as far as we can, because I know that's how you're going to find the answers left in a textbook, and I want you to be able to check your answers if you're doing homework questions. So the way we can simplify this now is factoring out the 32 over 15, which was already there. Then I'm going to take out this 8, which is as 1 over 8. And I will also take out from over here the 1 over 4. So take that out. So that leaves me with an x squared minus 4 to the 3/2. And inside the last set of parentheses, remember 1/4 was taken out from those two terms, so we're left with 5 plus 3x squared minus 12. And notice 4 times 8 is 32, canceling with the 32 up here. So we are left with 1 over 15 times x squared minus 4 to the 3/2 times excuse me, this one up here was 20, because I had 4 times 5 up there, so that was a 20 up there. So now in the last parentheses I have 20 minus 12, which is 8, plus 3x squared plus c. So I think this is pretty much as far as we can go in simplifying our final answer here.